All right, so the last lesson was two-dimensional figures. All right, what are some of the two-dimensional figures that we learned? We had a whole list of them. Remember that? All these polygons. What kind of polygons did we learn? Heptagon. What? Octagon. Give me some. What about 3 sides? Triangle, 4 sides. Okay, and so on and so on. Right. Pentagon, all that good stuff. So now what we're going to do is we're going to do something that maybe not quite as familiar. All right. These words are kind of weird. So basically today is just knowing. I'm not even going to do any math, I don't think. Let's see. I didn't take any notes on this because I can't really draw these pictures by hand. It's just too difficult. Yeah. Yeah, they're cube-like things. You know, they're 3-dimensional. So yeah, absolutely. All right. Now the first one, what I should do is just, because I don't have the first one here. I'll tell you what I'll do. Let's see if my internet works. What do I want? Sphere. I don't know, picture. All right, there we go. There's some spheres. That's a good one. So, come on. Let's do this. I'll just, I'll copy it. Will it paste if I copy it? Yes, it does. Well, we got that white background, but that's okay. I could have done this where I got rid of that white background, but I'm not going to take the time. This is good enough. Okay, so let's do that. So the first word is this thing right here. It's not a circle, but it's kind of similar to a circle. It's got circular characteristics to it, doesn't it? Anybody, any idea what we call this in geometry? A sphere, right? That's kind of a funny word to say, isn't it? Sphere. We don't usually put those together, all right? But that's what we call it. So let's write it down. So it's called a sphere. S-P-H-E-R-E. Do we have any other words in our language with the S-P-H? A Sphinx. That's a good one. What is it? Sophia? No, that's not. Sephora. Isn't there like some perfume or something like that? Sephora or I don't know. Anyway, Sephora. That's what. Oh, but that's got an E though, doesn't it? Anyway, good enough. All right, Sphinx is good. That's good off the top of your head. I would have not thought of that. But sphere. That's the name of it. It's basically just a what in everyday life? A ball. Okay, a ball. All right. It's basically a ball. All right. That's what a sphere is. It's got 3 dimensions. Now look, where are the 3 dimensions? Well, you've got a length, you got a width, and you got a height, or sometimes we call it a depth, right? And that's 3-dimensional. Okay, we're drawing it on a 2-dimensional surface, right? So it's kind of hard to draw something that pops out. Maybe 20 years from now, maybe they'll have things on a screen where it could be 3-dimensional, right? And then you could actually like grab it from here, hold it here, toss it back and forth. That would be super cool, wouldn't it? It would be, but we can't do it now. But we can at least look at it. We can at least look at it on a 2-dimensional surface, all right? But that's what it is. See that little oval-looking thing right there? I got way too many people talking. I'm trying to talk, and I can hear my volume getting louder and louder because I'm trying to talk over you. So just let me talk. So do you see that kind of oval, that darker yellowish-looking color in there? All right, it's not really an oval, but what it's doing, it's like a cross-section of the sphere. Like if you cut the sphere right in half, all right, it would look like this. And it wouldn't look like an oval. What would that be? If I took the top off of it and I looked, it would look like a circle, wouldn't it? Even though here it kind of looks like an oval. Everybody see that? But if in real life, it would be a circle. So we have to understand the way they're drawing things on a 2-dimensional surface and how it relates to our mind looking at it in 3 dimensions. Does that make sense? All right, so a lot of these pictures are going to be the same kind of thing. We're going to be using dotted lines and all this kind of stuff to represent a 3-dimensional figure. All right, so that's a sphere. We're not going to learn any equations or anything like that. Okay, we're just learning what the picture looks like and what the word is that associates with it. Okay, they give you a big old definition of it. You know what? I'm not even going to worry about it. Let's do another one. And we might as well just, I should have had these all ready to go for you, and I used to. Last couple of years I did, but this time I don't. So I'm going to put cone, geometry picture. All right, so let's see. There we go. All right, here's a simple. Let's do a nice color one. Oh, that blue one, that's pretty. Isn't it? So let's copy that. If you're watching on YouTube, YouTube doesn't see me going to the internet. They just see this thing right here. So this right here is a cone. So let's write that down. All right, so to tell you the truth, well, I'm going to write cone right here. Oops, I forgot to. There we go. I'm going to write cone right here. But if you look at it, what's the bottom of this cone? What kind of shape? It's a circle, okay? So the bottom is a circle, and the center of the circle would probably be about right in there. Would you agree? All right, and if I took a line and I went straight up, see how it would hit the top of it? Okay, and the radius of that circle on the bottom would go to here. What kind of angle does it look like we have? A right angle. Yeah, very good, because we learned that just the other day, right? Learned about right angles. So we call this specifically, we call this a right. What's the bottom of it? Now, what's the very bottom of this? Okay, it's a circle, so we're going to call it a right circular cone. All right. So a cone comes to a point. I was going to draw that. See the point right there? Okay. It comes to a point, and we call that point the vertex. That kind of makes sense, right? We've done vertex before, so that right there is called the vertex. Okay. The bottom, the circle on the bottom is called, what do you think the bottom is? Starts with B, but it's not bottom. It's the base. Very good. So we're going to refer to that a lot. Okay, so what it's sitting on, the circle at the bottom of it, is the base of the cone. All right. And why is it a right circular cone? I should have put a little right symbol there, okay, to show it was a right angle. Now, you could have cones that are slanted, okay, one way or the other, and still have a circular bottom. All right. But it would not be a right circular cone then. Let's see. Yeah, that's good enough. All right. We would call that, if it slants, I tell you what, let's see if Google will give us one. I'm going to put, the word is oblique. Let's see if they give us. Come on, interwebs. It's not giving it to me. Is it moving? Yeah, it's going in circles. My internet is slow today. Why is it so slow? It's like ripping fast this morning. There we go. And it gives you definition. There we go. So let's put them next to each other. That's a good one to have. I'm going to copy that. Put it right here. Well, I'll tell you what. Let's do this. Let's take this. Move it over a little bit. And then we're going to put this here. You see the difference? Yeah. See, it's oblique. You see where the center, where it's coming straight down? All right. So it's oblique because the sides of it, right, the outside of it, it slants. The bottom's still a circle, still comes to a point, still a cone, and you still have a right angle right here, but it's not a right because all the sides, the center at the top is not right over the center at the bottom. You see that? The vertex right here would be directly over top of the center of the circle of the base. Same thing here. See, the vertex is here, the base is here, there's the center of the circle. But look at this. Here's the top of it. If you drew straight down, perpendicular, we haven't used that word yet, have we? If you draw it as a right angle, straight down, it would not be at the center. So that would be an oblique cone. We go to that? Again, all we're doing is definitions. Okay, I'm going to show you pictures. So on a quiz or a test, I'll just give you a couple pictures, and you just have to tell me what it is. So this would be a what? A right circular cone. All right, this would be a sphere. All right. This would be an oblique circular cone. You got it? All right, I'm not going to write that down because it's right here already. All right, let's do another one. And again, I'll go to the internet. Hopefully it'll work for us. Let's do a right cylinder, right circular cylinder. All right, there we go. Oh, question? Go ahead. Are we doing what? Yeah. All right, here we go. So I got me right there. So let's take a look at it. Let's go to white again. So this is not called a cone. What is it? It's a cylinder, because look at the difference. It still has a circular base, though, doesn't it? And the walls of it go straight up. They don't come to a what? A point. They don't come to a point. So what comes to a point? What kind of shape comes to a point? If you have a circular bottom, a cylinder. All right. A cone. I just looked at cylinder. Right. It's a cone. Look at this one. The walls of it, you see the outside walls of it? It just goes completely straight up. And it's flat on the top, flat on the bottom. So the base and the top of it, which is also called the base, right? We call them both the base, even though this is the top and that's the bottom. They're both considered the base because they're exactly the same shape. We good with that? Ooh. Yes, I'm running out of time, aren't I? So we may have to finish up the rest of it a little bit later, meaning tomorrow, but that's okay. Let's do one more. Let's do an oblique. Let's throw in oblique. I don't know. We'll make a decision tomorrow. So oblique. Come on. It's going in circles. So what do you think an oblique cylinder is going to look like? It's going to look the same thing, except what? Instead of the walls going straight up, it's going to do what? It's going to go slanted. That's right. So yeah, here's a good side by side. So let's copy that image and we'll put it right here. There you go. All right, everybody, they cut it off a little bit, but you get the idea. All right, so this is a right circular what? No? Cylinder. What is this one called? It's a right circular, well, it's actually, I'm sorry, it's not right, it's what? It's an oblique circular cylinder, okay? Because look at the walls, they slant. Do you see that? This one just goes straight up and down, so that's right. When they slant, what do we use? Oblique, all right? So that's what we use there. All right, we didn't finish everything, so I'm not going to give you homework. So we're going to talk about, but I will give you homework tomorrow, and in the lesson plan, we didn't have homework. So we may possibly move the test till Friday. It was supposed to be Thursday. I don't like giving tests on Fridays, but that's okay. We'll give it on Friday, all right? And we'll finish this up tomorrow. Maybe I'll find all these pictures so I don't have to do a search every single time.